Good morning to all of you. Today we shall dig little deeper into the standard template libraries. As I was telling you, there is vector, there is list, and there is map. So let's see the distinction between the three. Look at this diagram that we have a vector here. So vector, when you declare as of type int, okay, so this reference variable will be allocated space in the stack, whereas this actual vector gets stored in the heap, and the allocation is contiguous. Okay, so you get a contiguous allocation of memory for the vector, right? And then when you declare a list of again integers, it's a doubly linked list. You might have all learnt linked list. So doubly linked list, you can traverse on both the directions. So the marks reference variable again gets allocated on the stack, whereas this doubly linked list is allocated in the heap, but this time it's not contiguous. Okay, so individual nodes may be allocated in different memory location and they are linked to the pointers. So you have a forward pointer and a backward pointer. The first node backward pointer is null and the last node forward pointer is null. Okay, and this is how the elements are stored. Now if you want to search any element in the vector, you just have to use the index. So like if I say marks of 2, it will refer to this element 0, 1, 2. Okay, so it's a random access. Whereas if you want to access any element in the doubly linked list, if you have the reference to the first node, you have to go on traversing. Let us say you want to search for access 15, then you have to go to the first element, then advance this by 1, go to this element and then print it. Okay, so it's going to be a sequential access in case of doubly linked list. Now if you want to insert any element in the list, in the vector it is difficult. As you can see, if I want to insert some number in this position, then these two elements have to be shifted next to positions. That is 2 and 7 should go here. Sorry, 2 and 7 should go here, and the third, whatever number you want to store, this has to be pushed here. So this is insert. So insert is very difficult in vector. Whereas in doubly linked list, if you want to insert any element, if you know the position of the node where you want to insert, then just that you have to create one more node here, let's say some 21, and you have to alter the pointers. You want to insert after 15, the node gets allocated here. These pointers have to be adjusted like this. Okay, so insertion is easier in doubly linked list, right? And if you look at the map, this is a binary tree. As I told you, it has two parts, key and value. The first part is the key and second part is the value. It's a pair of values. So the reason why it is organized in the form of a tree is that insert, delete operations, even the search operation takes log n time. If there are n elements, it would take log n time. Let's say there are 64 elements. So log of 64 is some 6. So only 6 operations are required to perform insert, delete or search operation. Alright. And the actual binary tree is of type red black. So there is a concept of red black tree. Using that concept, the tree always remains balanced. What are these balanced trees? We shall see in data structures in detail. The main idea is this tree will remain balanced. It will not become a skewed tree like this. Let us say you are go on adding the values. If the tree grows in only one direction, this is called a skewed tree. Okay. Whereas a balanced tree, whenever you do insert or delete, this always gets a shape which is more or less balanced like that. Okay, so the height of the tree is always maintained. You will have elements on either side of the root. This is the root node. Okay, so now you understand what is the difference between a vector, a list and a map. Okay, so in the previous class we were discussing these three things. Of course, we are doing some operations without knowing actually how a list is different from a vector. But now it is pretty clear that what is a vector, what is a list, and what is a map. Okay. So to access the elements, you can use index in vector, and you can also use an iterator. As I told you, an iterator you can define using the auto keyword. And if I say it equal to, you have to give the name of the uh, variable and then say begin here. So this will return the reference pointer.
Sorry to interrupt, sir. Can you just give a quick summary of that list, map, and vector?
Oh, you joined now, huh?
Yes, sir. 2 minutes back I joined, but I was not able to understand the context of it.
Oh, okay, okay. Yeah, quickly.
Just quickly, if you can just say that is fine, sir.
Yeah, yeah. See, the distinction is a vector is an array and contiguous allocation. Okay, whereas a linked list is again like an array, but it is a doubly linked list, and the allocation is not contiguous. Each node will occupy different memory locations, and they are linked to the pointers like this, forward pointer and the backward pointer. And insertion in vector is difficult, because if you want to insert value at position 2, let's say 0 1 2, at this 2 has to be shifted to position 7, and 7 has to be shifted next, and the new element has to be inserted here. Okay, and if you have a large vector, then many elements have to be shifted. Whereas in linked list, it is pretty easy. You just go to the node where you want to insert, create a new node, and only alter the pointers so that the new node gets inserted in fixed amount of time, irrespective of length of the linked list. Whereas map is a key value pair kind of a, and it is built using red black tree, where you have a tree like structure. And the red black comes because each node will be marked as red or black depending on how it is easiest to balance the tree. In fact, when we learn data structures in detail, we shall see how red black trees are constructed. So whenever you insert a new node, the tree remains balanced, and the search becomes easier, and the search time is log n. Whereas in linked list, if you want to search, if the length of the linked list is n, it would almost take n by 2 time. That is 100 nodes are there. You may have to search for almost 50% of the elements. Whereas in binary tree, it is log 100, which is close to some 7 or 8. Okay, so the number of searches or comparison operations that are required in a map is much lower compared to linked list data structure. Okay, whereas in vector it is easy. You just go to, it is a random access. You just do the index of the element you want to search. It will quickly give you in fixed amount of time. Okay, so this is a quick comparison. Now,
So map is going to take the key value pair, is it, sir? That is what you
no, you only have to specify the key. It will store key value pair. If you want to search for an element, you just have to give the key. There is a find method which will help you to find the required element from the map. So if you want to navigate through the vector or a list or a map, you can use an iterator. An iterator is a pointer like thing. If you don't know particular type of data structure you are using, you can just use the auto keyword. It will automatically detect that marks is vector type, and it will cast it accordingly. So it is now pointing to the beginning of the list. You can advance the iterator to any position. Let's say if I say it plus equal to 2, it means it is pointing to the third element here. It will, if I just say it equal to marks begin, it will be pointing to the 0th element, and if I do plus 2, it will point to 0 1 2. That is, if I print it now using dereference operator, what element do you expect? I should get 20 here. Let's see whether we get 20. Okay, so depending on how much increment you do, accordingly the value will be displayed. If I do plus 4, it will go to the fifth element, that is 11 will be displayed. Okay, so you can go to any element in the list But what happens if you go past the list? Let us say if I say 11 here. So there is no automatic boundary check. You will get random result. Okay. So you have to check whether you are within the bounds or not. As you can see, it is displaying some random value here. It will not throw any error, but it is your responsibility to see that IT is within the end of the list. You should do like this: if IT less than this marks dot end, you can also say equal to, then only display this, otherwise don't display. So this conditional check you have to do. So this time it will not display anything, okay, because it has gone past the list. So you can use an iterator to iterate through the vector, and you can jump the elements. You can start with 0 and go to fourth element, fifth element directly like that. Whereas in linked list you cannot do that. Okay, so let's see what happens if I try to do that in linked list. If I say it equal to, now there is a list here, ages, which is again of integers. If I say ages dot begin, so this will also return you an iterator. Now if you directly try to print, so now it is pointing to this list here, and it will show age as 28. And linked list is not contiguous. You cannot jump the list with larger than 1 value. You have to advance the iterator by 1, and now if you print, it will print 42. So you cannot use IT plus plus here, because it is not like contiguous memory location. You can go to the next element using incrementing the iterator. You have to use advance function to do that. If you advance by 2, it will go to the third element 19, and you can go on doing like that. Okay, so we can advance the iterator into the list and display different element. I also told you that in list insertion is easier. It is not that you cannot insert in vector, but it is going to take longer time. So if you want to insert into a list, you just have to say insert and indicate where the element has to be inserted using the iterator and what value you want to insert. So initially I iterated at the beginning of the list, and if you display the entire list, for example, if I use auto x colon ages and just print all the values here, instead of end I will use a space here. Now 22 should be inserted in place of 28, and you should get the new list. I inserted 22 in place of 28, and the whole list gets shifted. And if you want to insert at some other position, you have to advance the pointer by whatever value you want. Let's say 3. What will happen now? Iterator is initially at 28. If I say advance it comma 3, it will be 0, 1, 2, 3. So in place of 24, 22 will be inserted. Let's see whether it is. So in place of 24, 22 will be inserted, and 24, 25 will be shifted to the right. Okay. So insertion can be done very easily in list. So much is clear. Insert at particular position can be done. You can push back to the last element. All that can be done. Okay. And similarly, you can find a particular element in the list. Okay. So that is also possible. It will return an iterator, and you can print that particular element. We shall see more of these things as we move on. Now, what I am interested in showing you is how do I create a list containing some structure object like employee. So list employee, all employees. This is the list of employee objects. Now I can insert or put element into the create employee. So just to save time, if you observe, employee is a class containing 2 data members, integer employee ID and employee name. I have purposely kept them public because I want to use these two in some operation later. In fact, all the 3 members are public. though it is violating encapsulation principle, just to demonstrate how quickly you can access individual elements and perform some particular action. So there is a constructor which will initialize all three, and there is a display method which will display employee ID, name and salary. So to insert objects of employee, I just have to create certain values here.
Sir, it should be pushback or popback, sir. Pushback, right?
Oh yeah, pushback will put the element at the end always. So like this I can push some elements into the list. Now we have done this yesterday, but I am repeating it because I want to show one more operation, how we can use a lambda to perform that. Now that we have pushed three objects, to display them you can use auto x colon all employees x dot display, right? So this will display the data about each employee in the list. So it is displaying all these three. Now how do I perform a search for this, whether a particular employee with particular ID exists or not? Okay, so for that what I can do is here we have to give all emps dot begin comma all emps dot end, and here suppose if you want to find out on particular employee ID, I can put a lambda here. Let us say whatever employee ID you are searching is coming from outside this. So let me define employee ID equal to, let's say, 101. So I will pass that to the lambda, and within this const employee reference variable e, and within the body of this, let's say, return employee ID equal to e dot eid. If the employee exists, then you have to use a iterator here. So this find if is a built-in algorithm available in the algorithm library. You have to use it. So what it does is you are providing the beginning and end of the list, and you are providing an external value employee ID to the lambda. So the lambda will take each object in the list. Okay, so that is object E, and go on comparing. If that particular object exists, it will return the reference to that object. Now here if I want to print the object that you are searching, just you have to say it, let us say you want to display the name. So what it will do, you got the iterator to the object in the list, you want to access the employee name which matches the employee ID 101. So we know this is what I should get as the output. Let's see. Yeah. So this we know this found here. Now suppose if it is 102, I should get output as Girish. Right? So I am able to search in the list and display that particular object. Right? So creating a list, navigating to the list through the list and searching for a particular object in the list is all possible with the list data structure. Okay, and you cannot directly say find 101. You have to use find if algorithm and provide the beginning and end of the list, and also give a lambda which will do that comparison. Okay, similarly if you wanted to find on name, what change you would have done? You would have declared a string e name here. Let us say you want to search for then instead of employee ID, you would have passed e name here, and within this you would have written e name equal to e dot e name. Okay, and probably you might have displayed the corresponding salary. So if you look at Vinod, his salary is some 1000, so 1000 is what should come out. Okay, so I'm able to search for the employee based on the name and display the other parts of the object. You can display employee ID and his salary, or all the three, depending on what you want to display. Okay, so we are able to navigate through the list using the iterator, and also find a particular object in the list using the find div. So far so good. Hello.
Yes, sir.
Yeah. Now map is the next thing where.
Can we just try for
Oh,
a
you want to try?
right?
Yeah, yeah. Go ahead, go ahead. Let's see. Yeah. So let me display this
If
part.
everyone is fine.
Yeah, just check. All of you want to try
Yes, sir.
this for some time?
Yes, sir. We want
Okay,
to
so
try.
give a try. See, yeah, this is the usage of vector and list, right? So, how does it differ in map? So, map we have to provide two parts. First is the integer part, and second is an object part. It need not be always int, it can be float or it can be string, anything, but just for illustrative purpose, I have used key as the integer and value as the object of employee class. Now the way to add elements to this map is using insert. Okay, so if I say insert in flower bracket, I must provide the first part is your key, and second part is your object employee. Here employee ID, employee name, and salary. Okay, this is one way of inserting. Another way of inserting is name of the map dot insert. Then if you don't want to use flower bracket, you say make pair, and within round bracket you put the key first and then the object. So if you want to use round brackets, use make pair function you use, and then the key values have to be specified within round bracket, right? There is another way also. Infosys employees, you instead of insert you say emplace, and in round bracket you can provide the values. Employee 1, 2, and then something. So there are three ways of inserting. One is insert directly in flower bracket, second is insert make pair, third is using emplace. So all three will do the same thing. Okay. And now if you want to use an iterator to iterate through the object, auto it equal to Infosys employees dot begin. And you can display one of the objects if you want to see out IT arrow display, if you say. Yeah, so here we have to use first. There is a property called first. It will display the key part of it, and then you want to display the value part of it. Then you say IT arrow second dot get, let's say you want to display ename or you want to call display method itself, both are fine. Okay, so yeah, display you cannot put arrow and display here, that's a problem. So what we can do is we can call the getters to display each of them. Employee ID, anyway the first part is displaying. Get ename we can do, and then leave a space, it arrow second dot get salary. So it's a little different when it comes to map. You cannot directly access the members of the class using the getters. Okay, you have to use the iterator arrow and use the keyword second and then use it. Get salary. So do you have get salary here? Get salary is there in. Okay, so it is getting confused with this. I have to close this. Yeah, and again there is a problem. Yeah, what happened is I am using the same iterator IT, and that is where it is causing problem. So I should use a different name here, IT underscore 1 as an iterator, so that it doesn't clash with the iterator we have used in other parts of the program. Hopefully it will go through now. Okay, so it is pointing to the first object in the map, and it is displaying the corresponding name and salary. 93.99 point. Okay, this 20 is coming from something else, so I should put an endl here, so that the data that is getting displayed is correctly interpretable. Okay. Now this is one way of accessing particular object, that is you use IT1 to point to that object. Now if you want to go to a particular object, instead of begin you can say find and specify, let us say, the key. So this will directly go to 102 and display the name of the employee and the salary. Okay, so here it's not going to do sequentially, it's going to do in a binary search way, because it's a red black tree. The search would be a lot faster. Since you have only 3 objects, it doesn't make much difference, but imagine there are hundreds of employees when you want to do search. So login would perform better in map instead of using a list and trying to search in the list. That goes sequentially. Okay, so this is a map where you can directly reach out a particular node and display it. And if you want to display all the objects, you can use the iterator begin and you can do that. For instance, here if I say begin and you can put up a while loop, while it underscore 1 not equal to Infosys employees dot end. Underscore So it will display all the employees. Okay, so I'm able to display the first employee, second employee, and the third employee using the loop here. So IT plus IT underscore 1 will take it to next node in the list. Now all the elements will be always sorted on the key. For example, if I want to alter this order and make this 100 and this, even now when you iterate, so you, okay, so there is a duplicate here. Okay, so there are two objects with the same ID, that is, I should have changed it here, just 1 minute. The key has to be changed. This is 102 and this is 101 as it is, and this is 100. So all the three objects have to be displayed. As you can see, even though I inserted in different order, in the reverse order, it is always showing sorted list. Okay, so the values of the objects will always be sorted on the key. Okay, so that is
So
one.
here key and the employee ID both are same, right? And that can be different, no?
Yeah, that can be different because key can be different and purposely I have kept it same. If you make it, let us say 1000 here, 1001, 1002, something like that. Okay.
Okay. And that has to be integer always?
So I kept this as 1000. This should be 1001. And not necessarily, it can be string also.
Okay.
Because employee, assuming that the key is employee ID can be alphanumeric, no? Let us say E100 or something. Then you can keep the key as E101. But when you declare the map, this should be string. That is, you should declare like this: employee string, comma, employee like this, and then say Wipro employees. So in this case, when you insert, the key has to be alphanumeric.
String.
Yeah.
Okay. Can we try this?
Yeah, try this out. It, binary tree does not allow duplicates, so if you keep the same key, it will not be displayed again. So it was displaying only 2 because the third one, the key I kept it as 100 only. So now all the three keys are different. So as you can see, it is always sorted on the key.
So what if the key is string? Then also it will get sorted.
Pardon?
Key is string. If key is string,
Ah,
then it will get sorted comparing the string comparison.
yeah,
or
string
what?
comparison, string comparison. So just for completeness, maybe I will show you Wipro employees also. So as you can observe in the Wipro employee map, the key is a string. So even if the keys are differently ordered, so as you can see, accordingly Praveen came on the top and 103 went to the bottom. The corresponding employee details are displayed correctly. Just to summarize what we have discussed today, we saw how these three things are different. Vector is an array which is dynamic and gets contiguous memory allocation. List is dynamic list which gets allocation in the heap, and again the allocation space is not contiguous, it is spread wherever there is available space. And map is a red black binary tree. We can insert objects into vector, insert objects into list, and perform search or find based on some condition, etc. We have seen through that an example of an employee. Similarly, in map, you can insert using three different methods. Okay, insert, make pair, and emplace. And you can also iterate through all the objects in the tree using a range loop, like for each loop, or else you can use an iterator, and until you hit the end of the iterator, you go on advancing the iterator by one position and display all the objects in the map. Okay, so there is a method to go to a particular object in the map and display that, which I am not able to figure out how. There is a specific syntax which we shall see in the next lecture. All right.